Hello everyone, this is Vamshi Chinda. This is my final project presentation which is on comparative analysis of LiDAR and SfM point clouds. The objective of this project is to evaluate how well LiDAR and SfM point clouds perform in terrain modeling. I focused on comparing their point density, volume density, and surface variation. In addition, I generated compared digital terrain models and digital surface models to see which gives more reliable results. Here you can see the upper one is a LiDAR one and the lower one is a SfM point cloud. So they are not same. So I have to clip it and crop to get the common area for better results. Here you can see this is the clipped area from the above datasets. The study area is Malaket Beach located in Corpus Christi, Texas, in Texas. The dataset was collected by the Mantis Lab at Texas A&M University, Corpus Christi, under the supervision of Dr. Michael Starrett. For SSFM, about 16 million points were captured using UAV imagery, and classification was done using LAStools. And for LiDAR, I used about 15 million airborne points processed with single pass classification using AEP SG6578 projection. First, I started clipping both the datasets to get the common area for my analysis. Then after, I used the statistical outlier removal for the cleaning of the SFM dataset. Then for the classification of ground and non-ground points, I used LAStools. I used three different accuracy levels for the SFM dataset to get the better output of non-ground points. Because in the first step, I got a lot of vegetation in the ground point. So I used 10 and 15. Both got the same type of results. Then after LiDAR data was classified in a single step using a urban setting. Next, created that digital terrain models and digital surface models using minimum and maximum height projections with a 5 centimeter grid resolution. Finally, I used CloudCompare again to extract the surface density, volume density, and surface variation using different neighborhood radius for SFM and LiDAR. The results I got like the SfM DSM is smooth but lacks surface detail, especially in vegetated areas. LiDAR DSM is very sharper and captures fine elevation, captures more features accurately, making it better for detailed surface model. Here you can see the upper one is a light SFM data and the bottom one is the LiDAR. This is the comparison of digital terrain model of SFM and LiDAR. SFM DTM struggles with ground clarity, especially in dense zones. LiDAR provides a cleaner, more precise ground model with a better terrain definition, ideal for elevation analysis. This slide shows the density metrics comparison. LiDAR had nearly 3 times the surface density and over 5 times the volume density compared to the SFM. It also offered better vertical accuracy and geometric precision. Meanwhile, SFM data was more variable and less detailed in areas with the poor lighting or texture. This shows how LiDAR's higher consistency and point coverage make it but more suitable for precision applications. From this project, I concluded that LiDAR outperformed SFM in terms of density, accuracy, and ease of classification. It's ideal for higher resolution mapping and reliable terrain detection with minimal tuning. SFM still has its own uses, particularly for general surveys where cost and accessibility are the main concerns. My final recommendations is to use LiDAR for precision terrain products and SfM for faster low cost service. Thank you.